Hello everyone, I am Samad from KID and I am here to give a brief introduction to our project. So basically these are my project partner. First of all, SAQIB, Sheikh, Alyan and AREEB. So we are immensely grateful to our advisor Mr. Hasib Malik and supervisor Mr. Bezaman for the guidance and support. So our aim to design this application is that we design this application for the needy people who can't afford gynae fees and for time saving as well. Application ultrasound AI powered ultrasound application. So this is our banner. So first of all, here are problem statement and project scope, and given below our group members. First, AREEB member SYED, Sheikh Alyan, and me, Abdul Samad. I'm gonna share some ERD's use case and activity diagrams, system block diagram, how it will work in our application. So first of all, this is our use case diagram. Any user, healthcare professional or maybe patient. So first of all, they or he can upload any ultrasound image. Then then second step is the analyze. If our image is uploaded, then it analyzes our ultrasound image and enable real-time monitoring, update health records, and provide our visualized result, which is our output image. Okay, so second is our activity diagram. So basically, any healthcare professional or system user or patient. So system user have access to UI, patient have access real-time monitoring, and third one is healthcare professional, and a healthcare professional can upload any ultrasound image, which is gonna like if image is uploaded, so it check whether it is upload or not. Then it analyze ultrasound image and then comes the part with fetal health indicators directed, and also select real-time monitoring, or if real-time monitoring is if the image is gone like perfectly working, so it enable real-time monitoring, whether display no health indicators and detected. So basically this is our unit model which is working on the back end.
Set. We obtained this data set from various references, and the main challenge was to understand this data set. Though Dr. Talat Naz was the gynecologist who helped us in understanding the data set, then we conclude that we have four key parameters in our dataset: abdominal circumference, head circumference, biparietal diameter, and female length. And on these four parameters, we will train our model. Now over to Alyan.
After acquiring all the images, we first divide the images into 70-30 ratio for training and test. On the training images, first we make the segmented region of each image on Microsoft Paint. After this, we put all the images to Google Colab. We use Google Colab, Tester T4 GPU. For training purpose, we train all the images on UNet model, UNet architecture. Over to Mr. Ravi.
An Android application, we use Java as our programming language and Android Studio as our IDE. We incorporated our train entities of AC, BPD, HC, and FL in our Android application. So the Android application takes an image as an input, and through these entities, it produces an output result for the required parameter.
So now we would like to demonstrate the functionality.
So now we'll show you how we trained our model, how we trained our four parameters. So this is the AC abdominal circumference we trained. We've used, as we've told you, we've used the unit model architecture. And now these are the layers, and in this section, we have described our model. And same as this. And now this is the training and validation accuracy. and that is the testing. We test this model. So these are the output. Now same as that, we've trained our BPD parameter by paralateral diameter, and same training and validation accuracy. But in BPD we have different, little different in this, because we were in BPD we were calculating the diameter of the head. Now we have four different machines for femur length. So we Volusion E6 is the one. Then we have S10 machine. Then we have a Loka machine. So we've trained all these images. Now, Alyan.
Okay, so let me share my screen. After the training on Google Colab, we make the test code on the Python file. We first upload all the models in this. These are the object models that we have downloaded from the Google Colab file. So first we make the functions of ellipse and estimate ellipse length by these formulas. And these are making ellipse on the contour, which are the biggest contour, which is segmented region. For each, we make the API of each machine, each parameter with like AC and PPD. And there are, as you know, that there are four machines of femur. So each machine having different route. Here is the route of Volusion E6 and Volusion S10, Volusion S8, and following Volusion S8, here's Aloka. Thank you.
Okay, so now we'll move on to our Android application that we have made for our project. We use Java as our programming language, and we use Android Studio as our main IDE to make this Android application. So first we made a main page from where we can move on to login and sign up, as you can see here. And now this is our login page, and this is our sign up activity. After that, we will move on to our main dashboard, from where we can select our parameter that we have to work on, or we have to upload our image for that parameter. As you can see, there are many parameters for that: abdominal, BPD, Aloka, and many others. So for there, if we select abdominal, for example, so we can move here to this screen. Uh, Here we can choose our image for abdominal circumference, and from there we can upload our image that will go on to our API and fetch our details for that. We have trained our entities for that. As you can see here, we have our ID for our trained models, from where we can get these. If we go to the back end of this code, let me see of this abdominal. Here we are. As you can see here, uh, just wait a minute. Here, we just declare all our buttons and text views here. And if we go down, just wait a minute. So we made this upload image method, from where we can send our image to our main IPE of our Python, and from here we get our results, and we use retrofit our main library for client server connection, and we import all these here in our dependencies. As you can see, here our main retrofits library, and we use Picasso for our main image work. So when we upload this image to the server, then it will produce our result. As I'll show you all these activities in another video, or where we can run our Android application, and we'll see all the results and all the work that we are doing here. Okay. So here is our mobile application. As I show you, there are two main screens: login and sign up. So first I'll show you sign up. Wait a minute. This is sign up, and from where you can sign in. If we have already signed in then we'll directly go to the login. Here we enter our credential, that is email and password. So here I'm going to write my credentials. This is my email, and for password I'll write my password, and then when I click on login, so it show me successfully login. I click OK, and there are parameters. I click on abdominal, and here I'll have to choose an image. So simply I click on the button choose image, and here it will take it to my gallery, from where I have to pick my image. So here are my folders. I click on this one, I pick an image of abdominal, and then I click on the upload image button. So when I click on the upload image button, it will go to the server, and then it will check my results. So here are my results. As you can see, it makes an ellipse on the abdominal, as it highlighted the abdominal part of the image, and then it will predict its mask, and here it show me the axis of major axis and estimated length of that abdominals. So from where we can predict the abdominal behavior of that baby. So here it is, and then we can do it for more parameters. So here it is our main. Thank you so much. We have clicked on log. Right. Thank you.